amended to improve drainage, typically with organic materials. With the selection of appropriate materials, macro pore space can be increased. However, drainage improvement may require the addition of a substantial amount of amendment and needs to be done prior to landscape development. In soils where water infiltration is slow, steps can be taken to avoid standing water. Slow water application can help prevent puddling and runoff. If the problem is caused by compaction, soil aeration may also be considered. Irrigation should not be applied faster than water can infiltrate. Even with proper care, there are limitations to the effectiveness of maintenance practices in controlling drainage. Careful plant selection is important in choosing trees that will adapt to the soil's drainage conditions. In highly developed areas, the large concentration of impervious surfaces interfere and can greatly reduce water infiltration into the soil. As a result, stormwater runoff is a major concern in many urban areas. In order to keep streets and sidewalks clear, runoff is often channeled through a series of gutters, canals, and storm drains, and is then directed to a nearby body of water or processed in a wastewater treatment facility. As water flows over streets, parking lots, and other hardscape elements, it carries pollutants with it, such as motor oil and de-icing salts. If left untreated, this water can severely degrade the water quality of nearby lakes and rivers. However, treating stormwater before it enters a local watershed is costly, and large rain events may overload water treatment facilities. As a result, reducing overland water flow and increasing water infiltration into the soil is both environmentally and economically beneficial. A rain garden is a landscape feature specifically designed to collect and hold stormwater runoff. They are often incorporated in a landscape to capture water from parking lots, downspouts, or sloping lawns. While the plants incorporated in a rain garden must be tolerant of periodic flooding, a rain garden will not always be filled with water. Plants should also be tolerant of dry periods, or supplemental irrigation will likely be necessary. Both native and non-native perennials, shrubs, and trees are often incorporated in rain garden designs. Water is vital to plants. Without sufficient soil moisture, a tree becomes dehydrated, stops growing, and overall plant health can decline. On the other hand, too much water can cause tree decline as well. Maintaining adequate amounts of water in the root zone, not too much or too little, is critical for tree health and growth. Various terms are used to describe both water retention and water loss. When gravitational water has drained away after rainfall or irrigation, soil is at field capacity and has reached its water holding capacity, which varies with soil texture, sand, silt, and clay content. At field capacity, water is retained in the micropores either as capillary, available water, or hygroscopic, unavailable water. Irrigation may be necessary for trees growing in areas that do not receive rainfall throughout the year and for species that are not adapted to extended periods of drought. Irrigation requirements vary with species, size, and environmental conditions. The need for irrigation can be reduced or even eliminated if proper planning and plant selection are able to match the site's environmental conditions with the tree's water requirements. Sprinkler systems can apply water uniformly across the root zone of a tree. However, sprinkler applications may lead to water runoff, erosion, and crusting of the top layer of soil. Limiting application times to match infiltration rates and using low application heads can minimize these problems. Drip irrigation systems apply water slowly to localized areas of the tree root zone, reducing the potential for runoff, erosion, and water loss by evaporation, but require frequent monitoring to ensure emitters are functioning properly and are placed efficiently. Other tree irrigation methods include high-pressure water injection, soaker hoses, basin irrigation, and temporary and portable drip systems. Many systems are designed and installed primarily to irrigate turf and other landscape plantings, resulting in excessive irrigation of trees. Tree species adapted to dry summers and native to such climates are prone to widespread fungal problems associated with frequent irrigation. In addition, root system damage may occur during installation of below-ground irrigation systems. Damage can be minimized by proper system design and use of pneumatic air tools rather than mechanical trenchers. Water is a very limited resource in many areas, making conservation an integral part of water management programs. Minimum irrigation provides only the water needed to maintain tree health, growth, and appearance using efficient application methods. This requires an understanding of water budgets, plant and soil water loss, evapotranspiration, ET, water holding capacity, application rate, infiltration rate, and irrigation system efficiency. Water loss and water availability information is combined to determine appropriate irrigation schedules. Irrigating with recycled water may result in a water source with high levels of salts as well as other chemicals, which can raise the soil pH, increase soil salinity, cause problems with phytotoxicity, and clog irrigation nozzles. Recycled water can also be high in essential elements such as nitrogen, phosphorus, and sulfur. The success rate in using recycled water depends mostly on the soil type, water quality, and sensitivity of the plants to salts. It is important to monitor soil conditions and plant health frequently when irrigating with recycled water. Organic mulches are materials placed on the soil surface to reduce moisture evaporation and improve soil conditions. A layer of mulch, not to exceed 2 to 4 inches, 5 to 10 centimeters, in depth, reduces water evaporation from the soil, minimizes weed competition, reduces soil erosion, can improve soil aeration, and moderates soil temperature. Organic mulch adds organic matter to the soil as it decomposes, enhancing soil biology, fertility, and structure. Inorganic mulch, such as crushed stone, requires less frequent replenishment but provides fewer benefits to the tree. Antitranspirants are chemicals sprayed on plants to reduce water loss through transpiration. The spray forms a thin coating on the foliage which reduces water loss through the stomates. Antitranspirants have been used to reduce drought stress, prevent fungal infections, and minimize the effects of winter burn on conifers and broad-leaved evergreens. They are also commonly applied to transplanted trees that will be transported long distances. The effectiveness of antitranspirants, however, may be reduced due to tree species, environment, and weather conditions, and may be phytotoxic to some species. Flooding can be very damaging to trees. In poorly drained soil, low percolation rate, water can occupy macropore space for extended periods, restricting air movement. Lack of oxygen, anaerobic conditions, suffocates roots, changes the chemical composition of essential elements, can create mineral toxicities, and can lead to fermentation in root cells. Lack of oxygen can also harm the living components of the soil ecosystem. The longer the excess water remains, the more tree health deteriorates. Trees that survive flood conditions may suffer long-term consequences and should be inspected for related damage. Preventing drainage problems is a key strategy for limiting injury to trees. For an undeveloped site, adjusting the grade may help avoid drainage problems. If a developed site drains poorly, drain tiles can be installed to carry excess gravitational water away from the soil. Surface drainage may be improved by changing the grade or trenching, and soil may be amended prior to landscape development to increase macropore space and improve drainage. Careful plant selection is also important in choosing trees that will adapt to the soil's drainage conditions.